Start.
Good morning, students. Today we will see the minor loss for the given pipe. Here, the two diameter pipes are given. One is the 2.5 centimeter and another one is the 1.5 centimeter pipe. And here, inlet pipe is connected to the motor and outlet pipe is connected to a contraction and elongation end, and one pipe bend is there. So, once the motor is started, the water will be coming through the inlet pipe and it is passed through the elongation part and as well as contraction part in the given pipe, and we want to adjust the discharge valve. Once if we adjust the discharge valve, the manometer reading will be changed. So we want to note the reading of H1 in the left lane and H2 in the right lane. At the same time, in the given collecting tank, for every 10 centimeter rise of water, we want to note the time taken. So if we note the time taken and we want to calculate the area, and H is the 10 centimeter, so actual discharge will be calculated. When the actual discharge is calculated, using the minor loss due to the contraction formula, we will calculate the minor loss for the pipe contraction. Similarly, for the pipe elongation also, using the formula, we can calculate the minor loss for the elongation. So, only the elongation and contraction will be calculated using the given formula in this experiment. Thank you.
Next part is the ablation part in the minor loss. As we know, the minor loss is a pipe due to the sudden expansion and pipe due to the sudden contraction and pipe due to the bend and whatever the other cases also is there. But mainly we noted the here is the pipe is due to the sudden expansion and second part is pipe is due to the sudden contraction. The first part is the sudden expansion. If we know the first tabular column, that is the difference in the manometer reading, and the difference in the manometer reading we know already, that is the H1 is the left limb reading and the H2 is the right limb reading, and the pressure difference is calculated using the formula, that is the specific gravity of mercury by specific gravity of water minus 1 into the difference in the manometer reading. Then third part is the time required for the 10 centimeter rise in the collecting tank, and fourth part is the actual discharge, that is the AH by T, that is A equal to area of the collecting tank and the H is the 10 centimeter rise and T is the time taken. And inlet velocity and outlet velocity will be find out using the continuity equation only, that is a Q equal to AV. That Q is actual discharge can be find out already before itself. The next part is the inlet velocity and outlet velocity. So the two diameters will be available. Using the two diameters, the inlet velocity and the outlet velocity can be find out. Then using the formula, that is a V1 square minus V2 square by 2G, the sudden expansion can be find out, that is the loss of the head can be find out. The second part is the sudden contraction. What the procedure we find out the sudden expansion, the same procedure only here also we will carry it out. The difference only is the for last part only, that is the formula part only, is that head loss due to the contraction is the 0.5 V2 square by 2G. That is the only the difference. The remaining part is the same part only. Here also the difference in the manometer reading is calculated and the pressure air loss is calculated using the specific gravity of the mercury by specific gravity of water minus 1, and the time taken for 10 centimeter rise in the collecting tank also is noted. Then the actual discharge is calculated using the A into H by T, that is a area of the collecting tank, but H is the 10 centimeter rise by T is the time taken. Then outlet velocity is find out using the continuity equation. The last part is the head loss due to the contraction. So if the average of all the reading, we will give the head loss due to the contraction. Thank you.